So we're going to be talking about, this is kind of a little different than what we've been doing as far as the quadratic. I mean, it kind of applies to quadratic equations still, but we're going to be talking about solving these nonlinear systems. So there's actually three ways you could do it. Not exactly that particular, like I don't really have a huge preference on which ones you follow. But there is an easier way, I guess, for all this. But let's talk about using a graphing calculator first for this. The really easy first step is if you want to graph or just by graphing, you want to make sure both your equations are in the form of y equals. And then two, you could graph, you could use your calculator or Desmos, or if you're feeling ambitious, you can graph by hand. Big smiley face if you do that. So I'm just going to take these two equations. I'm just going to go right into Desmos with them. So I'll go to my Desmos graphing calculator. It's great if you haven't used it yet. It's a phenomenal tool. I'm just going to type them in. So I got y equals 3x minus 20. Just like that. And I got y is equal to 3x squared. I should have saw that whole thing. 3x squared. What is it? Minus 21x plus 2. So this is what a nonlinear system looks like. Notice they're not both lines. That's what this linear systems where there are two lines that cross. And I'm just going to be looking for their intersection. If you need help on your graphing calculator, please stop by office hours because everyone has a different calculator and it's a little bit, it'd be easier just for me to show each of you individually if you can't figure it out on your own. And Desmos is great because everyone hopefully can access Desmos. But you click, and you'll see right there, boom, there's one answer. Boom, there's one answer. So I got one answer, 1.056 comma negative 16.832. Or 1.0, so you can round to the nearest hundredth, 1.06 and negative 16.83. And then 6.94 comma 0.83. So there's the first way to graph. I like graphing. It's great. It's kind of cool to see the visual, especially when you zoom out what's going on. And you might see some fun equations like, oh, maybe the graph of a circle, x squared plus y, like 3y squared equals 27. Oops, I guess I'm gonna have to go 104. Boom, and like look at that, you have a cool oval with two answers here now. So just different ways to find answers in different graphs you're gonna see. Just one can be a line, but both of them aren't gonna always be lines. So there's graphing. Substitution requires a little bit extra work here. So the substitution step, the first thing we're going to do is isolate one of the variables. So isolate a variable in one of the equations. So the easiest thing I think for me is the y right here in the second one. Because if I subtract 2x on both sides, I'm just left with, y is equal to 7 minus 2x. So that's kind of nice. I'm going to plug that in to the other equation. So I'm going to take this and plug it in for y. So I'll get x squared plus 2x minus 7 minus 2x equals 5. And step 3 is solve for x's. It's plural, there's 2. So we'll solve for my x's. Okay. Boom, distribute that negative. So x squared plus 2x minus 7 plus 2x equals 5. And add 7 on both. Actually, so I know this needs to be equal to 0. And combine those. And then subtract 5. So I get x squared plus 4x minus 12 equals 0. Now, does that factor? I think it does. Two numbers that add up to 4 and multiply to negative 12. That'd be 6 and negative 2. Oh, good. So we don't have to do quadratic formula or complete the square or anything. So x plus 6, x minus 2 equals 0. Apply my zero product property. So I get x is equal to negative 6 and x is equal to 2. Great. So now I have that done. X equals negative 6, x equals 2. Step 4 is plug each x into one equation to get my y's. So I'm going to pick the bottom equation because I like it better. It's easier. It's less work. There's no square terms. It's easiest that way. So I have 2x We'll start when x is equal to, I'll do two different colors. So let's do blue. So when x is equal to -6. So I'll do 2 times -6 plus y is equal to 7. So -12 plus y is equal to 7. So y is equal to 19. So my final answer is -6, 19. There's 1. Let's do the green. So I'll have x is equal to 2. So 2 times 2 plus y is equal to 7. 4 plus y is equal to 7. And so y is equal to 3. So my next answer is 2 comma 3. I think substitution is my favorite method. I feel like it's less work, but you'll see in the next one, elimination kind of works as well. It's in the last method, elimination. Very much like when we did the systems of equations, you might need to see if necessary. Step 1, if necessary. If necessary. Well, actually, step 1, choose variable to eliminate. Step 2, this is going to be a lot of steps, I guess. Align variables or like terms, I guess. Align your like terms. And step 3, again, if necessary, you might need to multiply 1 or both equations to get ready for elimination. So if you don't remember, in the first module, for instance, if this was 3, this would have to be a -3 in order to cancel out my x squareds. Step 4 will be add straight down or eliminate. Eliminate. Boom. This is already elimination ready, so I chose the y's. They're already aligned, and I don't have to do any multiplication. So I basically skip steps 1 through 3 here. When I add straight down, I end it with 4x squared is equal to -32. Okay, so I divide both sides by 4. X squared is equal to -8. And I take the square root of both sides. Oh, I can't take the square root of both sides in this case because that is a -8, which means we're done. There is no solution to the system. So that means these are probably not crossing anywhere. So it could look something like the quadratic. Here's my quadratic, my graph. Could look like this. Sometimes they just don't cross and we have no solution. All right, probably the quickest section, one of the quickest sections of the course right there. So if you need questions, please stop in office hours, seek out tutorial. Other than that, good luck in the rest of the module. And I'll see you in the discussion boards.